Well, I'm reading books and papers on physics. And I'm not a philosopher of physics. So the question is, what am I exactly doing when I'm doing that? I'm also meeting mathematicians and physicists, I mean actual physicists, to try and get them interested in my problems, in some conceptual problems. Or sometimes I'm putting together workshops on philosophy and quantum gravity with someone who's sitting here, Gabriel Catran, who will be talking this afternoon. And well, when it comes to contemporary science, and more precisely physical science, contemporary physics, the question arises inevitably in connection with the boring subject. How does a philosopher with a very minimal training in mathematics, in my case, relate to the available material and seemingly very exciting material out there? How do we work? Even if, again, this, even though the work can be up to a point collaborative, there are exchanges, there are moments, they're quite rare, I think, such as this one, but mostly it's a rather solitary work. I mean, we're confronted with the suffocating amount of knowledge and also the painful realization of our own finitude when we're standing on my side, the philosopher. So what can be done? I think the best thing is to focus on one particular issue I've been confronted with for years now. I think sometime during the middle of my PhD years, I realized that I had a personal obsession with time, and that I had to confront my obsession with the actual findings, the conceptual elaboration of temporal notions that was going on in physics, of course. But let me first confess something about philosophy, to make things clear. I have a rather classical conception, view of the task that a philosopher should uphold. I mean, I believe I have this notion that philosophy in its purest state, I mean, where it's closer to its actual essence, is something that was traditionally called metaphysics. I mean, this is where philosophy marks a clear difference with other types of theoretical or critical inquiries. It's qua metaphysics, I think. Now, metaphysics can be fully inventive, of course. There are new metaphysics every 20 years, maybe. But I'm afraid it turns upon a limited set of very traditional grand problems. I'm pretty much convinced of this. The invention that characterizes the production of new systems, new doctrines in that field takes place at another level. Not the problems themselves, but I'd say the invention of new perspectives or new lines of sight. So the great or grand problems, I think, need not be overturned or deconstructed endlessly. They only need to be refurbished from time to time, or rather, upgraded. And by this I mean formulated in a more precise way, with greater precision. And that's where particular sciences, I mean the positive sciences out there, come into play. They are instruments of precision for the philosopher. This is not very original, this idea. I take directly from Bergson, Henry Bergson, who himself, I think, spent most of his time reading science. Before publishing a few essays, as he called them, in philosophy, he read and digested and assimilated a lot of scientific ideas in order to achieve that level of precision, precisely. So the worst, when it comes to science and philosophy, the worst case scenario is quite familiar. It's philosophers borrowing from theories with which they are more or less familiar, certain images, so the idea of quantum superposition, and then applying it to a totally different field with no real regard for the precision of the concept. Or it could be, again, borrowing certain general themes, identifying certain general themes such as relativity, and then again projecting upon this notion whatever they please. And well, this is the worst case scenario, and I think most interesting philosophers in the field avoid this easy temptation. And then I guess the standard situation involves two things. I describe this as intensification on the one hand and generalization. These again are two temptations, and these are very difficult to avoid. Intensification, generalization. What do I mean by these terms? The first idea, intensification, is in fact mostly useless to scientists. It involves going a little further than the scientists in the direction of making explicit the methodology or the underlying rational principles that are really already at work in scientific activity. So it's the idea that philosophy could provide a sort of more articulated epistemology of what the physicist is already doing, right? So intensifying the movement and clarifying to a point the operations of a scientific rationality. The other idea, generalization, is the idea that, well, the philosopher, as a specialist for generalities, is here to provide a sort of a synthesis, to take possession, as much as he can, of existing science, to bring it to increased levels of generality, and to proceed from condensation to what could be called a unification of knowledge. This expression, the unification of knowledge, was quite popular down to the 30s and 40s. It was a research program among philosophers of the logical positivist variety. And of course, today the problem is not even scientists. I think no single scientist can claim today to be able to take possession of science as a whole. So not speaking of philosophers, okay? And even if the philosopher was indeed able to achieve that particular sort of synthesis, the synthesis of contemporary knowledge, scientific knowledge, I think it would be probably useless as far as philosophy is concerned. Here again, I quote from Bergson. Bergson said, "The process by which philosophy seems to assimilate the result of positive science should not be a synthesis, but an analysis," which may sound surprising coming from Bergson. He claimed that the proper role of philosophy was to provide an analysis of science. In what sense? Well, let me put it negatively once more. It's not a matter, and again I quote from Bergson, it's not a matter of advancing farther than science in the same direction as science. It's not a matter of carrying the results of science to a higher level of generality, but of using scientific knowledge as a crucible in which to melt new, more precise instruments for thought. And by this, we should understand for philosophical thought or for critical thought. We should use scientific formats, rather vague designations. I don't want to say theories, let's say formats, ways of representing the world. We should use them as filters or as percolators. I like the metaphor, right? It's an image of the percolator, the good espresso machine, to extract what? New intuitions. New intuitions that can be put to work to expand, to complicate certain traditional problems of philosophy. That's the way I see it. So how do we extract new intuitions from science? So here I think it's important for us to keep in mind how science, generally speaking, actually works. I take from Poincaré, which is an author I've very much liked, on which I have worked from the philosophical side at some point. I took from Poincaré the following lesson, that science operates by means of a simplification of the real. And so part of the so-called unreasonable effectiveness of mathematics in its applications to physical science comes down to this. The real that physical science is dealing with has already been simplified or reduced to a kind of a sketch. And as a result, mathematics is so effective because it deals not directly with reality itself or even the phenomenal plane, but with its projection, its projected image onto the plane of operational thought. So in some sense, you could say that abstraction is a precondition for conceptualization, not the result of conceptualization. You first need to abstract, and then you can operate and build up concepts and theories. Experience must first be stripped from all or part of its qualitative noise, if you like, so that it lends itself to mathematical formalization. This is rather trivial, but it needs to be borne in mind. Of course, there are some things that resist. I mean, mathematical formalization is not immediate, and it, at some point, and that's where science is probably addressing the real. At some point, there are things that resist, but this resistance is always experimented at a level which is not the mere observational registering of facts. It always involves a measure of abstraction and conceptualization. So I leave this aside. But now, what about intuitions? Again, how does philosophy manage to pitch itself against science? Once we've acknowledged that science is dealing with reality in this very particular way, which is to first project an image of reality onto an operational plane, and then to a formalized plane, and then actively elaborate the concepts that would help scientific activity to tune into reality, but from this level of abstraction from which it starts. How does the philosopher creep in, so to speak, in this general situation? Again, it's not a matter of synthesis, of reaching this high level of generality where the big picture becomes apparent and the themes can be brought out, and you can pretty much extract a worldview from contemporary science. I mean, worldviews are already out there, they're all over the place, and I think the job of philosophy is to get rid of most of this worldview in order to get to the real stuff. The real stuff is obtained in relation to science by recovering, I would say, the full spectrum of possibilities or potentialities involved in the formalization plane of science. And this is achieved by slowing down scientific activities. So from Hegel, this time I take this notion that a philosopher is an immense operation of breaking, slowing down the speed of thought. Mathematicians go so fast. Physicists a little slower, but still very, very fast. So Gabriel knows about it because he's both a philosopher and a physicist. I don't know how you manage to combine these two levels of temporality, but definitely philosophy takes time for a good reason. Conceptual elaboration and, in a non-Hegelian sense, Bergsonian sense, the recovering of intuitions or the working out of intuitions to get them ever more precise requires time, because it needs to slow down scientific activity to recover the potentialities that are generally left aside by the physicists or the mathematicians who directly wants to go to the point. So it's a matter of re-densifying, not reality itself, is in this kind of naive pseudo-phenomenological idea that, well, something has been left aside of reality, well, whatever you want to call it, the quality, the body, the sensible. That's not the point. What needs to be recovered and re-densified is the rich content, not of experience, not the qualitative content of experience, but of the formal field itself. The philosopher, instance, dwells upon the formal field of science as a parasite, and taking his time or her time, try to uncover the potentialities left aside by scientific activity and which are in fact to be found on that plane, in the formal field opened up by science. So this requires not only time, I'd say, but again, using a metaphor, a particular position or attitude which I could describe as looking at science sideways. So I don't know how to perform this. That would be the plane. You need to get the proper relief, the things that are generally hidden from view for when the physicist riding a drone or whatever vehicle speeds off quickly above the plane and just and does his job. You need to sit and look at things sideways to see to catch new patterns, to discern new figures in the carpet. Referring to Henry James' short story, The Figure in the Carpet. So the idea is to extract from the formal plane where scientific theorizing operates a philosophical intuition, but to extract it sort of by surprise or against the will of the scientist, or most of the time again, not against his knowledge, but he doesn't know about it, basically. So this idea of stolen intuitions turns philosophy into an activity of pilfering. So I looked up my dictionary. This word exists. I didn't know about it. Pilfering, because extortion sounded a bit harsh. I mean, it's gratifying for the philosopher to picture himself as extorting intuitions from the scientist. But again, the scientist is not interested most of the time. And it's not a matter of forcing him to yield anything, but simply to, pilfer. When he's not looking around, hop, you grab something and bring it back home and just think about it for a while. And this, of course, does not conform to any, I should emphasize, any of the established definition of philosophy of science, right? Okay. So now I'll give an example, as I announced. I'll give an idea of the kind of activity I'm involved, of pilfering activity I'm involved in on a daily basis. But first, a few more quotations from Bergson, my man. I just said that, and I said it several times, that the process by which philosophy assimilates or seems to do so the results of science is not by way of synthesis, but analysis. Now you understand what I mean by analysis. It's not logical analysis of the structure of scientific theories. It's this particular analytic gaze that tries and identify bits and scraps that have been left over in the process of scientific production. Or again, but then we're not naive enough to just come unarmed, unprepared. We have an intuition. We have an inkling of what's going to be interesting in the field, of course. That's where I can quote Bergson once more. The philosopher does not arrive at unity, he starts from it. He comes equipped with an intuition, a pre-notion of unity, of how things will fit together in a general picture. He comes equipped with intuitions, but the problem is his intuitions are vague. So when I said that he could relate to science as a provider of intuitions, it's not that the intuitions are provided ready-made by science. It's more that our intuitions, philosophical intuitions, are vague and need to be, again, refined, made more precise by being pitched against the exactness of scientific formats, scientific formalization. Last quote. As the diver, the diver would be the philosopher involved in this activity of pilfering. As the diver fills out the wreck on the seafloor, that the aviator, so the aviator is a double of himself, is him having brought in philosophical intuitions, but vague, hazy intuitions. As the diver fills out the wreck on the seafloor that the aviator has pointed out from the air, so the intellect, and by this he means the philosophical intellect, immersed in the conceptual environment of science, verifies from point to point, this is the analytic aspect, from point to point, by contact, analytically, what had been the object of a synthetic and super-intellectual vision. So you have to get off the plane, dive in the water, and actually palpate the contours of the wreck. So it's not only pilfering, but a kind of semi-archaeological activity which looks at science not directly where it's happening. We're not good enough for that. We're not quick enough for that. So we're dealing with the wrecks, with things, the leftovers. So we start with a vague intuition, which is already the anticipation of a problem and the way things are going to fit together. We feel that the multiplicity of scientific artifacts form a nexus and somehow connect to experience at large. Science spells out the nexus of things in terms of causal relations, laws of nature, invariant structures across time. But we know, I say here, I speak for everyone, not only the philosopher, we know that things also exist together in a more fundamental sense. They coexist, and they do so at various levels of reality, even if they're not directly related or connected by traceable physical processes. And this is my issue. The way I approach these days, this past month and years, the way I've been approaching matters of contemporary physics was through this lens, this intuition that physics had something this idea in itself is by no means original, that physics had something important, fundamental to tell us about the way things hang together, and more precisely coexist in the most general sense of that term. And in order to make this intuition of the coexistence of things more precise, I feel the necessity to dive, to palpate the wreck, and to come back with weird objects which fit together in some sense, can help me make sense of this coexistence of things, the tota simul, if you like Latin words, tota simul, the wholeness of everything at once. And in order just simply to give you an idea, and this will be more or less the conclusion of my talk, rather lengthy conclusion, I'm afraid, but it will be more of a sampling of images and things I'm interested in. I would like to focus on this issue, how to make sense of coexistence, and show you where exactly I, as a philosopher, can find an interest in contemporary science, certain aspects of contemporary science, and also have a hard time, I should confess, even addressing this issue with actual physicists, because they're far, far ahead of me. They've already solved so many problems, and they've left many things aside that I'm picking up on the way, and just waving at him, saying, "Yeah, you forgot this," and they look at this and say, "No, you don't need that." And I'm in the difficult position of picking up bits and scraps and trying to make something like a weird toy with it, and trying to get my father interested in it, and looks at me sometimes in a nice way, patiently, and he would even accept an invitation to a colloquium and share some ideas, but my problems are not his. We shouldn't fool ourselves. This is the painful part of the experience. So the most interactions with scientists is a bit frustrating, because you can discuss up to a point, but then you soon realize that, well, he's working on a set of problems which are his problems. And the level of generality where you position yourself doesn't allow you to really enter in the detail of his problems. And the very generality of your problems, he has a difficult to make sense of. So there's a discrepancy here that we could discuss maybe from different angles during the day. I think it's one of the issues. It's easy to exchange views, but to really reach an agreement of what counts as a problem, it's a more difficult task. So my problem, again, is coexistence. Let me give you a sense of the problem by just zooming in on context of experience. So here the students who attended the past 3 days in my seminar will see if things resonate, because I'm going to use some of the examples we discussed at large in detail. The first one was discussed yesterday in our class. It's an amazing passage from the Diaries of a Phony War by Jean-Paul Sartre, where he describes a very ordinary, familiar experience of exchanging letters, having to wait for an answer. Of course, in those times, the digital means of digital correspondence didn't exist yet, but the problem is pretty much the same, different scales. And what he points to is the very painful realization of the terrible simultaneity, he writes, the terrible simultaneity, which is sort of hollowed out by this very basic feeling that something's going out there as you're waiting for the answer, something from which you're radically expelled, because you have no means of connecting with it in any straightforward way, in any causal way, a physicist would say. You have to wait for the signal to be transmitted and to come back to you with an answer. In the meanwhile, this is a matter of coexistence, of simultaneity, what you become aware of is this central void, this central zone of radical indeterminacy, where you have no clue as to what's going on there. You can only hypothesize and project general ideas. You have the feeling that you're utterly disconnected. So I got interested reading and rereading this passage, which has very many aspects to it, and also strangely religious overtones. The bleeding heart of Jesus is mentioned at some point. And I just started reflecting on the strange combination of connection, co-presence, and disconnection or separation that is involved, sort of dialectics of connection and disconnection involved in the very idea of simultaneity. Very different setting, context, and it's another type of experience or quasi-experience, that of the sublime. Paragraph 27 of the third critique by Kant, analytic of the sublime. The sublime, and this is often overlooked by commentators, is firstly defined in terms of simultaneity. What is really painful for the imagination is not to embrace a lot, well, it is, of course, something that exceeds the power of synthesis. It's firstly that what is usually given successively, a multiplicity, must be apprehended in a regressive manner, a regression, which cancels out the time condition, which is the usual condition of the imagination, as a progression, synthesis of the multiple through progression. You have to sort of reverse the course of time and condense multiplicity into a simultaneous view, a survey of the situation. To make things simultaneously intuitionable, you need to indulge in this regression, which in itself does violence, he says, to the inner sense. So there again, you have this connection of the experience of simultaneity with the experience of the sublime. So connecting with what's going on out there in parallel, as I'm talking, connecting with Sasfe, its surrounding, and from there to the world at large, the worldwide instant or moment unfolding now, involves an essentially violent and painful operation of the mind. And there too, I think, there's something interesting in the kind of double injunction, the double bind involved in the very notion of simultaneity. You must intuit, but in a way that does violence to intuition. So how does physics, contemporary physics, contribute to this? Well, first let me, in two words, almost literally, clarify what I have, how the problem must first be spelled out philosophically in order for the philosopher to pitch it against scientific theories. A little work is needed, a little clarification of preliminary clarification of philosophical intuitions is needed before we embark on the boat of science. We need to do a little work to prepare the ground. And to keep things simple, I'd say the same Immanuel Kant, in his PhD dissertation, called, not really his PhD, in his 1770 dissertation, says two things, which I think are fundamental insights into simultaneity, and which you could directly link to very precise discussions going on today in the scientific field. So he says, first, simultaneity is not a sheerly spatial concept, it's a temporal concept. He says, literally, it's the most interesting idea derived from time. The most interesting idea derived from time, meaning it's a temporal concept. So it's a temporal concept. It doesn't reduce to the instantaneous given of space in its entirety. It's more than that. And the second thing he has to say in the same passage of the dissertation is, simultaneity cannot merely be defined as the negative or the absence of succession. You need to give some substance to the concept. It's not merely the fact of not being successive. So what is it? It's temporal but not successive. How can we how can we deal with such a concept? So he gives himself some clues, but I think basically those who concretely work on the causal nexus of things, the physicists explaining how things hold together as part of the same spatio-temporal universe, have something to contribute, for sure. That's the beginning of my involvement with science. Is following Kant's insight, I decided to look more closely into the matter. So now, since I have like maybe 3-4 minutes, I'll simply tell you how it worked for me historically. I spent about 5 or 6 years researching the Bergson-Einstein debate, which more or less turns around an incorrect interpretation of the status of time in relativity theory. So the debate took place in the 20s, but I should emphasize that it goes on. There are different actors, but today, for example, I referred to earlier to quantum gravity. There is a major issue regarding the status of time, of temporal concepts in quantum gravity, or if you like, the theories which try and come to terms with the problem of unifying theories of gravitation and quantum mechanics. Some people advocate the idea that the space-time structure itself emerges from a more primitive state. Call it pure variation, or what you prefer, and that as a result, the concept of time may not be as fundamental as you think. Some people relying only on general relativity already said that, have already been saying that for a long time, that time is an illusion, and so on and so forth. And as you know, one of Einstein's main popular claims, the way it's been transmitted to the wider public regarding relativity and already the special relativity, is that simultaneity is relative. It depends on the reference frame you adopt, the perspective you adopt on the universe, and as a result, being relative, non-absolute, it's not a fundamental concept. So, exit the problem of simultaneity. It can't be that simple, of course. And the fact that questions regarding the proper status of time or temporal concepts keep re-emerging in the history of the most recent physics is a symptom that something has not been digested, that something has not been properly thought. So the business of the philosopher is to first clarify the conceptual ground at this level of generality which he's comfortable with, and then dive in and try and follow the steps of the physicist, pick up the wreck or the leftovers, and try to make sense of simultaneity in a way that doesn't offer this easy exit. Time does not exist, just an illusion. It's confined in your mind. Don't bother about it. We can do physics without it. This is not enough. You can't be serious saying that, right? It's not serious. It's not, as is it Derrida who said about Alain Sokal n'est pas sérieux. It's not serious. So, my conclusion is almost entirely picturesque. I'll be showing the figures in the carpet that I identify in the spatio-temporal framework that has been established by Einstein-Minkowski right after the first formulation of relativity, 1905, and 1907, 1908. Minkowski provides the mathematical substructure of the relativistic concept in the form of a four-dimensional pseudo-Euclidean space-time. You've all heard about it. Okay. Yeah, okay, I had to skip a few things here. I was proud of this, so I'll just show this. I like this word. It's an archaic, almost primitive British word, the brangle of time, that I took from Berkeley. Berkeley says at some point in one of his dialogues, we're embrangled with time, or by time. And the word has an equivalent in Latin languages, imbroglio in Italian or maybe Spanish. embrouille, a term that I love in French, is also someone who wants to, looking for a quarrel with you, he's brangling with you, okay? And time, there is a brangle with time. Maybe with time would be more adequate. So the brangle started really in philosophy among physicists and philosophers between Einstein and Bergson. And I would say the root of the brangle, the source of the misunderstandings is the very concept of space-time, which gives a sense that time is, well, not fundamental, having been fused in some sense with space in the form of this unterrible, inseparable four-dimensional construct, where time is not merely a fourth dimension articulated as in a Cartesian product with the 3 dimensions of space, but really dimensions inherent at every in every portion of space and inherently articulated with the 3 others in a system of correspondence, if you like, or a system of transformation. It may seem that it has been dissolved in some sense, and that now the real entity we're dealing with is space-time. But my point is that if we look sideways again at space-time, let me find the most adequate representation. It's very difficult to give one picture of space-time. So there's many ways you could represent. Some of them are very, very imaginative. You could show. This is often shown in relation to general relativity. So you have a warped or bent fabric, for example, the planet Earth, kind of sitting on top of an elastic surface, and the surface being gently bent to suggest the bending or the warping of space-time. I'm not going to use those pictures, which I don't think are very illuminating, but the diagrams. So you should imagine space-time as being endowed with this topological structure, the double light cone, and I'll just say a few words about it. But this structure is attached to every point of space-time. It's been figured here for one particular point. So the question is, if I sit and look sideways at the picture, to recover information that is not interesting for the physicist. The physicist, as a matter of fact, is not really interested in the particular shape of this picture. What he sees, he has some. I think I'm always impressed by mathematicians because they have this kind of X-ray lens or glasses. They can see through things, through pictures. So here, most evidently, they immediately see a structure, a topological structure articulating levels or degrees of connection and disconnection. They'll see the projective structure embedded in here. The angles traced by these lines, which correspond here to the lines of virtual light rays emitted towards the point where the observer is located, or from the point where it's located towards the future. These angles, properly understood, suggest something of the underlying projective structure and also of the system of transformation and the group, the underlying transformation group of the so-called pseudo-Euclidean metric of relativistic spacetime, and so on. So, of course, the first thing to do is to get to familiarize yourself with this language and the implications, but then to sit and look, take some time daydreaming about this picture and seeing things emerge. The patterns emerge. And what I'll do, and it's my real conclusion, Chris, I don't want to delay or accumulate delay. No, well, a little bit. For once, the philosopher will have to rush. I will simply show what, and it's not a visionary activity. I mean, it involves using a pen and just retracing figures, opening up not only popular science book, but introductory manuals to relativity, the kind of thing that a student would use in sitting in a physics class, and recovering those more or less trivial patterns of simultaneity, which are again left over by the most of the time by the physicist. So the first is absolutely trivial and even not interesting, even for a philosopher, which is to say a lot. It's the fact of coexisting at one single space point. It's often in the physics literature, they will refer to this as coincidence. Coincidence is being here now together. So there's nothing much to say about that kind of simultaneity. All the more so as it's completely ideal. We're never sitting together, especially we high-grade organisms. We cannot fit together in one single point of space-time. We are thicker than that in space and time. Anyway, the other equally trivial, maybe less obviously so, but equally trivial notion of simultaneity is the fact that everything coexists in some general sense in the space-time block, as it's referred to in the current literature, philosophy of physics literature. We all coexist in the same space-time block, and this gives argument or support for the arguments of those who believe that time is an illusion, where the future states of ourselves are awaiting for us somewhere down the line in the same block. So it's universal coexistence, equally uninteresting, because what we need, of course, are local or regional concept of coexistence to make sense, for example, of Sartre's experience of simultaneity, which involves him and Simone de Beauvoir out there being involved in this strange correlation or mixed combination of connectedness and separation. We need something more interesting than that. So what I recover from the twins, the famous twins experiment or twins thought experiments introduced by Langevin is, and using an even more simplified and purely two-dimensional diagram here, is the sense that the twins as they go their own business when they're separated and then united again, the twins in the meanwhile somehow are contemporaries. It makes sense to say that while I was doing this, you were probably doing that or that. And so if their simultaneity cannot be assessed in any univocal way because of what Einstein described as the relativity of simultaneity, nonetheless, maybe topologically, it makes sense to say that since they share the same interval, topological interval or region in space-time, being separated at one particular together at one particular point of time, then separated and then reunited again somewhere down the line, they share something like an interval of simultaneity, which, for example, if these were the twins united and then reunited, they could follow different paths across space-time. But it makes sense to say that these paths, as diverse as they are, involving as much dilation of time as you like along each space-time trajectories, they are contemporaries in an obvious topological sense. And this notion of coexistence, so they coexist, simultaneity has an objective sense. This is not relative to any perspective or reference frame. I've been drawing this in space-time as it's currently represented without any notion of a reference frame. There is a frame, but this is the pictureless frame. It's not a reference frame. This is an absolute notion. It's intrinsic. You can recover it from any perspective, okay? And I have to say that this concept of coexistence has almost no value for a physicist, unless you're dealing with particular contexts in cosmology where this makes sense, but it's trivial. It's not even worth mentioning. I've submitted the idea, and other similar ideas, such as, this is of rather limited use, but still, it's another concept. It's what you could call hyperbolic simultaneity. I coined this expression. So it's the idea that if people or observers or any physical process departs from the same point in space-time in different directions, the directions and the angles represent speed, levels or degrees of speed. As a result of the dilation of time predicted by relativity theory, there's no way you can connect their durations in any absolute way. So they are sort of temporally disconnected. Nevertheless, if they all radiate, so to speak, from the same origin, you can define a line of equal proper time being the time, the local, the sheerly local time defined on each path. You can define lines of equal time, so they look like hyperboloids, and you could trace them all the way up. And consider that at these points of space-time, well, the same amount of proper time has elapsed. In some weird sense, you could say this is a line of simultaneity, of a very limited use. But this is typically a pattern that emerges from the physics that, of course, a physicist would acknowledge as being there in the general picture, but which he has limited use of. Again, qualification, this type of representation I have seen used in cosmology to, for example, to could figure this as the Big Bang. And the expansion of the universe can include a measure of hyperbolic simultaneity that can be of some use, limited use, to account for certain aspect of the theory. But it cannot be adopted as a kind of a replacement replacement for the missing concept of absolute simultaneity. It's a not only local concept, but it's entirely predicated upon one particular event or origin event. And so I could go on and submit other, I counted about 8 or 9 models of what I call regimes of coexistence that are, in fact, as a matter of fact, superposed within the topological representation of space-time, and again, somewhere in the vicinity of the light cone, or one I didn't mention because I'm doing this sampling rather randomly here. There would be a way of showing how they connect, of course, how you can derive possibly one from the other, but one which is most obvious, and I'll stop here, one which I've discussed at the very end of our seminar session yesterday, which was very clearly exposed, philosophically extracted and conceptually formulated by Whitehead, and which is the notion of contemporaneity. There you go. And again, it's a rather limited concept of simultaneity because it's centered upon one particular event. So this event could be you sitting here now, or any other physical process that you can locate in space-time. It's connected with all these other events outside its light cone. In other words, beyond any possibility of causal connection, of any connection that makes physical sense, because you'd have to go faster than light in order to connect this with these. All these events, in other words, all the four-dimensional space surrounding the light cone, external to the light cone, which Eddington called the absolute elsewhere, is made of events which could be, under some perspective, adopting a particular reference frame, considered to be simultaneous. Or, in other words, and more negatively, you could say, there's no way you can order them in succession. There's no absolute notion of succession between these events, although from a distance you might think that this one is further in the future than this one. But no, because you'll always find a perspective under which these two are actually simultaneous. And so if you consider this, you get a clear sense of all these as being contemporaries in some sense. They're contemporaries in the sense that from no perspective can they be successively ordered. But you see the implication, and I'll stop here. Philosophically, it's a rather powerful intuition into simultaneity. Maybe too powerful, maybe a little frightening. The idea that ultimately the core of what we call coexistence or simultaneity, what Kant had in view, and what maybe was really painful in the experience of the sublime, is not so much the sheer quantitative amount of information to be processed, as it is the realization that at the core of coexistence, or co-presence, there is this element of radical disconnection. In other words, for two, in Whitehead's language, for two events to be contemporaries, you need to make sure that they can never be connected in any physically relevant sense. So disconnection is the essence of coexistence. Powerful intuition that needs to be refined, made more precise, using more varied patterns from the physical carpet. And I'll stop here. Thank you.